Hi, and welcome to my channel TechneMoira. Today's episode is all about a Grundig Sonoclock 800 alarm clock. So grab your favorite snack or drink, sit back and enjoy. So I thought you and I would enjoy a simple little project before I shut down my channel for the summer. I may have said this in a previous episode, but I am going to take a summer break. I need it, not only to rest up, but also to do some stuff in and around the house. And I thought, as a symbolic parting, at least until next episode, I'd show you the restoration and repair of a cute clock radio I bought. I think I bought it on eBay, and I already restored a similar but older model of Grundig Sonoclock, link below this video. But I just love the design, the futuristic design. It's not quite what I would call 70s design. It misses that certain flair, I'd say, that the 70s design had. You could say 70s design is more rounded, not so angular as this model, but it's still reminiscent, let's say, of the 70s. Now, this clock was sold to me state unknown, and in fact the seller explicitly wrote that he didn't take back anything and he didn't give any sort of guarantee, which is okay. And when I took a look at the underside of the clock radio, I immediately realized why I wouldn't be getting any sort of warranty on this. So that it will need some repair, that is clear. But what the state of the devices inside, that we'll have to find out. Now, as it stands, I'll have to undo this mess here to open it up, I think, because somewhere underneath this there are screws hidden to open up the lower case. Alright, I'm aware some of you would probably love to have me plug it in and just to see it, just to see some magic smoke appear, or to hear a loud pop, or maybe even a big bang. But those who have been following my channel over the years know that that is not my style, okay? Everything I buy to restore and film for you guys, I do intend to keep, at least most of it. You could call it my own private little collection, so I'm not going to wantonly destroy it by plugging it in just to see if it works, okay? Also, on a completely different note, I think some of you may have noticed that when this video will be posted on my channel, I will probably have reached the first 1,000 subscribers to my channel, for which I'll be eternally grateful, and I'm extremely glad that many of you decided to subscribe to my channel. I know my channel is you could say a boutique channel, so it's not a channel that would be heavily popular among many people. It's certainly not something you'd find on Mr. Beast's channel or something like that. But nevertheless, as few subscribers as I have, I did manage to finally reach my first 1,000 subscribers, and I hope I will keep each and one of you happy over many more years to come, many more years of restoration and repairs, right? And thrown in between a few new designs of stuff, right? So there you go. I am going to take a break during the summer, and I think during the month of August I won't be putting up a new video. The next video will probably be at earliest beginning of September somewhere. Don't be impatient, I will be back, and I'm already having an idea of what to film for, let's say, the first 1,000 subscriber episode. I'm not quite sure yet, but I'm working on it. Alright, after a little bit of a closer inspection, I couldn't find any sort of breaks or cracks in the alarm clock, neither at the back nor at the front or the top. Sure, there are the usual dings and scratches, and there's a little bit of dust and dirt, but otherwise no, I don't really see any sort of significant damage, except of course what must be hidden under this tape here. So it could be any kind of damage. It could be a break, or maybe even something melted inside. We don't know. So as far as I can tell, what they used was a sort of duct tape. So what I'm going to do is I'm going to heat it with a hair dryer and gently heat it, and then hopefully the glue of the duct tape will become soft enough such that I can tear it away without damaging the case even more. Yeah, there must have been duct tape over here as well, and maybe at other spots too, but basically most of the duct tape is located here, and there's a battery holder here. So yeah, I don't know. So let me get ahead with it, and we'll see once I'm done. It's a pity though that they did place the duct tape over the original label of the clock. I mean, the serial number is obliterated now, but you know, such is the case many times with second-hand and vintage equipment, right? So it's often damaged in certain places which can't be repaired. So sound alarm, if you don't like to hear the sound of a hairdryer, then turn down your volume now. Now this is mysterious. Why would they have placed this dirty piece of duct tape over it? I mean, why? What's the use? And why this dirty piece of paper? I don't get it. This is weird. Okay, so anyway, there you go. The duct tape is removed. So I'm going to clean it a little bit because it's extremely sticky. But I'm going to use some alcohol and some petroleum, cleaning petroleum, to do that. Whenever you're confronted with old glue that you need to remove from an object, usually the first thing I do is to use some cleaning petroleum, okay, which is colorless, by the way. But if you wonder what this is to all intents and purposes really just regular gasoline for cars, right? So the only difference, of course, is that gasoline for cars is colored. I think either yellow or red, I'm not sure. This is colorless, okay? So if you want to clean clothing, I would advise you to use the colorless commercial cleaning petroleum rather than petroleum you get at a gas station, okay? Okay, taking out one screw at the back took care of opening it up, but have a look at this. I don't know if you guys can see this. Can you see how dirty this is? Do you see the dirt inside? Yeah. This thing more than likely has never been opened before. I'm fairly certain of that. And it's definitely and that's an understatement, it's definitely in urgent need for thorough cleaning. Also, I found this spring stuck to the magnet of the speaker. So obviously something let go, and I would say more than likely the snooze button let go, and therefore the spring for the snooze button let go as well. Yeah. So yeah, before I start seriously working on this, I think the best thing to do right now is to clean it as best as I can. Alright. I made the decision that to be able to work on the Clockradio, it would be better if I unmounted the main PCB, which also carries the power supply part, from the bottom of the case, right? Yeah, to do just that, I need to undo a few screws at the bottom, namely right here. So there's 1, 2, 3 screws. There are no other hidden screws, at least that I can see. So yeah, so that's what I'm going to do next. And once I unmounted it all, then I'll show you the result, right? So it's incredibly dirty, by the way, yeah, and you can tell, for example, here. let me show you a close-up of it. So right there, in fact right here, the wire is damaged. Yeah, right up to, in fact, the very electrical wire, so the copper inside the wire. So yeah, it definitely needs a closer look. And as you can tell from this distance, and from this angle rather, it's pretty dirty. It's really dirty, you know. But to be able to work on it easily, I really need to unmount the whole electronics part from the case. Alright, I hope you guys have a solid stomach, because this is what I discovered once I released the main PCB from the bottom plate of the Clockradio's case. You know, it's really not pretty, and I discovered a few weird things, you know, like for example this little piece of plastic here. I don't know what it is, and I don't know what its function must have been, but I'm going to set it aside just in case I discover its function. Also, apparently there is something with a there's a spring here, yeah, which was mounted under the PCB, the main PCB, close to the power supply section. I don't know what the function of this spring could have been. I don't know, maybe dampening of vibrations perhaps, or providing a sort of a grounding of some sort. I don't know, it's weird, you know. But as I will do with all the rest, I'll set it aside and I'll try to discover what its function is once everything is clean. Now, to remove the main PCB, what I had to do was to unmount the AC power cable, undo the two screws from the bottom, and then you need to pull gently on these plastic hooks right here. Okay, so there are two, 1 and 2, and lift the PCB just above the hook, you know, on both sides, and then release the buttons, the tuning and volume buttons, by lifting them gently, you know, and then pulling the whole assembly forward. Okay, and then for the battery backup, I had to pull it through this opening here. So there you go. That's how you basically release the main PCB. So what I'm going to do next is release the display panel, which I think will take releasing 4 screws. Okay, so if you look at the PCB, there's 1, 2, 3 and 4 screws to undo, and the same thing with the speaker. 4 screws, and the speaker should come from away from the front panel. Alright, the very first thing I'm going to do is to measure the fuse that I found on the board, and it's located right here. I don't know if you guys can see it, right there on the print board. Okay, so right here, and okay, there you go. So normally if the fuse is good, we should hear my multimeter beep, right? So here we go. Okay, so yeah, the fuse is good, and I'm really happy the engineers at Grundig didn't skimp on a fuse in their design, because that is something that I've noticed so many times. That is that manufacturers will try to save on a few cents by, for example, not mounting any sort of fuse or fusing mechanism in their design, right? So yeah, what I'm going to do next, before I go on, let me show you what the front panel looks like. So let me show you what the front panel looks like. Okay, and it seems to be powered by, let me rub off a little of the dirt, an LM8361 chip, you know, the main chip down there. I vaguely remember, or I remember vaguely the logo of the producer, but I'm not sure if it's Signetics or something. I have to look it up, which company used that logo. Anyway, there you are. It's surrounded by a few logic chips. There's one here, so let me show you in a close-up. There you go. So that's one of the logic chips surrounding it. It's an HCF 4069. I don't know what its function is. I need to look that up. Also, there is another chip. Let me show you. So the other chip is over there. Okay. And this chip is an MC 14572 UB. Don't ask me what it is. I've got no clue, but I suppose it must be a logic chip of some sort. I'll look it up and I'll let you know once I confirmed who produced it and what its function precisely is. It is a Motorola chip though. And that chip on the other side, so that chip is, if I'm not mistaken, is SGS. So I think that's a Signetics chip. The center main clock chip, I don't know which company produced those, so I need to look that up. Interesting little detail is right here, which is a light sensor, or you could say a light sensitive resistor. Okay, so which I presume was used or is used to set the overall brightness of the display. I'm going to unsolder the speaker. On one hand, to be able to clean it a little bit easier, and on the other hand to avoid damage it, right? So, and basically it takes unsoldering two wires, okay, a black and a green one, so it's really not that much work, and that way I know I'll keep the speaker intact, you know. Cleaning a speaker is really not that difficult. You need a medium hard brush like this. This is pork hair, by the way, so that's not extremely hard, but it's stiff enough to be able to take away dirt, like, you know, dust on the, as you can tell, on the cone of the speaker, right? So all I need to do is to brush it like this, and that way I could clean out the speaker without damaging it, right? Obviously, on the cone of a speaker, you shouldn't use any sort of cleaning liquids or stuff like that, okay? Because most of the time the cone of a speaker is built out of kind of a cardboard, okay? And cardboard is extremely hygroscopic, yes, meaning it will absorb moisture incredibly rapidly. Before I quote-unquote attack the main board with any sort of cleaning product, I try to get rid of most of the dirt with the same brush I used on the speaker, okay? So the reason being that as long as it's dry, some of the dust is easier to get rid of, you know, with a simple brush than with some cleaning product, right? So some of the dirt and grime has the tendency to stick to surfaces when you use cleaning liquids and stuff like that. So to give print boards a thorough cleaning, what I usually do is I use regular WD-40 in a spray can like this, right? And I just spray it with WD-40, and then I rub it with a brush, okay? And obviously I do it over a rag to absorb any of the spent WD-40, okay? So yeah, Here we go. Oh, wait a second. Can I? Oh, look at that. I can even pull off the buttons. That is nice. Okay. So I pulled off the buttons. So now I'm going to clean the display with some WD-40, like this. And rubbing it off with the brush. So this is going to take a while. I'm not going to make you watch it all, but once I'm done, I'll show you the result. Once I clean a PCB with a generous amount of WD-40, what I do next is use a contact cleaner to clean out things like switches and trimmers and stuff, you know, like this part here. Okay, so like these two parts, so the switch here, and the trimmer there. So I clean them out with contact cleaner, like that. Even the little potentiometer, you know. Switchers, trimmers, potentiometers, those I clean out with some contact cleaner after I cleaned the rest with WD-40. Now I use the contact cleaner sparingly because this is expensive stuff, you know. It's called Manol or Manol, and it's the type 9893 contact cleaner. It's industrial contact cleaner, and it's really perfect. The price is reasonable, although I wouldn't say it's really cheap, but it works quite well. I've used this kind of contact cleaner for ages. I'm not sponsored by them. This is paid for with my own money, but I just wanted you to know which type of contact cleaner I use. I decided that after a closer look, by the way, that the main PCB of the alarm clock wasn't clean enough, not by half, and I gave it a thorough cleaning with some industrial degreaser, and this is all the dirt that came out of it. Pretty gross, eh? So yeah, I think a superficial cleaning was never going to work out with it. So yeah, I gave it a pretty thorough cleaning, and at least now it'll be a pleasure to work on it because yeah, just like you, I'm pretty grossed out by dirt like this, you know. My guess is this alarm clock must have stood in some kitchen or maybe some working area somewhere, maybe, you know, in some industrial plant somewhere, but that's just a wild guess, of course. Either way, I did some internal shopping, which I mean by that I When to look for all the necessary electrolytic capacitors to replace in the alarm clock. Okay, there are 13 of them, so I made a list over there if you're interested. Alright, so 13 electrolytics in all will have to be replaced. You know, some in some impossible spots like that one. Okay, and then a couple over there, which will be a real pleasure, haha, to replace. Yeah, in the main, I think it shouldn't be too much of a problem to replace the electrolytics. So I'm not going to regale you with an hour-long video of me unsoldering and then resoldering electrolytics. Next you'll see a completely recapped alarm clock circuit. And when I say internal shopping, I mean by that I went to look in my own stock of replacement parts. Right, I have all sorts of drawers with all sorts of replacement capacitors of a wide range of values, and I found more or less what I needed in my own stock. The engineers at Grundig were so nice to indicate the polarity of the capacitors, the electrolytic capacitors, on the print board, right? So within the circle you see two rectangles, right? The full rectangle on the right is the ground or the cathode of the capacitor. The empty or hollowed out rectangle on the left is an indicator for the anode or the positive lead of the electrode, the electrolytic capacitor, right? So keep that in mind when you replace electrolytic capacitors. The polarity is always important. And that's why I often advise people to take pictures of whatever circuit you're going to work on, just in case you are a bit conflicted on what the exact orientation of electronic parts were. The astute among you will have noticed that there is a flat cable which connects the main board with the display board, right? And more than likely that will be for, among other things, power and other functions like the wake up function, right? Now, while I was replacing the electrolytics on the main board, I noticed this, and I wanted to share it with you all. So let's see if I can show you. So that row of pins are the wires of the flat cable that connect to the display board. And if you look really close, well, honestly, this is the worst row of cold solder joints I've ever seen. And I'm not exaggerating, this is not a hyperbola of mine. This is really bad. I mean, yeah, this is as bad a solder job as I've ever seen. And each one, or nearly each one of the connections is a cold solder joint, a really bad solder job. the one on the complete left, so that one over there, that one is mine. Okay, so that's one I repaired. So now I need to repair all these other ones, you know, to make sure that everything would work correctly, right? So yeah, if you ever wondered how a cold solder joint and a bad solder job looks like, well, there you go. So, by the way, I looked the clock chip up, and apparently the LM8361 was a clock chip produced by Sanyo, and the little symbol you see over there, that logo there, that is the Sanyo logo. Okay, the old one, in fact. So I don't know which logo Sanyo nowadays uses, if Sanyo still exists, but in the olden days that would have been Sanyo's logo. So there. That one, on the other hand, which is labeled SGS, is, I think, Signetics. Okay. The date code is from 88, by the way. So if you look at the lower part, you see 8834. Okay. So that chip would date from the year 1988. This chip has a date code, on the other hand, of 8405. So the 5th week of 84. That's pretty strange, wouldn't you say? I mean, so I'm not entirely sure that is the date code of that chip, but my first guess would be yes. 4 years difference between this one and that one. Alright, I cut off part of the AC power wire to the clock radio because it was damaged right here, you see, and it had the nearly identical kind of damage higher up, but that's where exactly I cut it off, this piece, from the wire, right there. So I'm going to create, in essence, the same kind of connection as they used to be. Okay, and the wire will be connected to these pins over here, right? These two pins over here. So yeah, and this wire is essentially undamaged, so I can place it back into the case without having to fear any sort of AC power leakage or short circuit or whatever, you know, because I'll admit to you all that I'm pretty paranoid where high voltage, you know, and high currents are concerned. You know, I really wouldn't like any sort of fire or short circuit or electrocution due to my inattention, right? So yeah, we're going to create a fresh connection which with undamaged wires, and I'm going to do it right there at these two contacts right here. this is the moment probably most of you have been waiting for, namely the moment where we will switch on the clock radio for the very first time. So all the capacitors on the print board, on all the print boards, have been replaced. Everything has been degreased, cleaned, so it's about as clean as I can get it, at least the electronics. And yeah, I think the moment is almost there that we can connect it up to the AC and then see if it works or not. Okay. I did connect it up to a connector box, which itself is connected to my Variac over there, and that one in turn is connected to the AC via an isolation transformer beneath it. Okay, so the thing behind my multimeter there. Alright, so should there be any short circuit or stuff like that, it's protected by multiple fuses. So there's a fuse in my Variac, there's one in the isolation transformer, and of course there are the fuses in the fuse box below in my house, right? So yeah, all I need to do is flick the switch on my Variac and see if the display comes on, and then maybe the radio. Yeah. So yeah, the speaker is connected, so yeah, I'm curious, and I'm sure some of you are too. So enough lollygagging. Let's just switch it on. Okay, 3, 2, 1. Okay, it didn't go boom. No, it didn't. It didn't explode in my face, so that's good. I can hear some noise from the speaker, but let's see. I can't hear anything else but noise. Let's unroll the antenna of the clock radio. Let's see if that helps. I'm not hearing anything. Unfortunately, the camera wasn't rolling when the LM8361 clock chip gave up the ghost. It just gave up a tiny little puff of smoke, and that was it. But before it gave up the soul, the radio did start to function normally. However, it did not display either time or alarm time. And neither did it display, well, it sort of displayed the seconds, but I don't think that was really reliable. I mean, the values it showed were, in my opinion, pretty random. I just couldn't set it. Now, apparently, without the chip, the radio won't function either. Yeah, I did measure some values on the print board. I mean voltage values, and specifically the voltage around the Zener diode D103, which is a 15 volt 1 watt Zener diode. That one over there. Okay, so I also inspected the little resistor beneath it, that one over there, which looked really, well, brownish, tarnished. But that's exactly what it is. It's just some dirt, some tar maybe, or grease, you know, which has over the years, well, hardened. Yeah. So it's really dirt. The resistor itself is okay. And so is the Zener diode. I did measure the value of the voltage at the pin of the Zener diode, and it measured minus 14.5 volts. Now, this is something else I wanted to tell you guys. Apparently, Sanyo designed the LM8361 to function with negative voltages. Okay, so yeah, strangely enough, it needs negative voltage to function and not the usual positive voltages we would expect. So that was a little bit surprising. Also, the display elements, yeah, those elements have a common cathode, just in case you're wondering what sort of display elements they are. They are common cathode display elements, and the type is HD1143R. And as far as I remember, the R stands for red, the color red. Okay. So yeah, there you go. So what I'm going to do, well, what I did was I unsoldered the LM8361 because, like I said, it's more than likely dead. And that was a pretty nasty job to do, you know, to unsolder it. That took me, well, that took me at least half an hour, maybe even 45 minutes, okay, because I just didn't want to damage the print board, okay. So yeah, I did install these little chip feet, you could say, yeah. Instead of a regular IC foot, let's say, yeah, because first of all they allow me to see the print board in its entirety, and second of all they offer better contact towards the pins of the IC. Okay, now in my stash I found a replacement LM8361. So what I'm going to do is I'm going to install the replacement IC, and then we're going to give it another try, right? Like I said, I measured the voltages. They seem to be okay. I don't see any short circuits on the board itself. So yeah, I think it's relatively safe to try it out. It's all connected to my variac over there, so I'm going to switch off the variac, then I'm going to install the new chip, and then we can have a go at it. Alright, so this is the replacement LM8361. It's also a Sanyo. Okay, so I don't know if you guys can see this, but I'm going to take it out of its protective package, and then we can install it on its board, right? Now I have to say these chips are quite sensitive to static electricity. So before you will unpack the chip, you have to make sure, you have to make certain that you are not statically charged. Yeah. In other words, I would advise you to touch something metallic or even a ground earthing or something like that to discharge yourself from static electricity. Okay, because like I said, these chips are very, very sensitive to static electricity, which is unfortunate, you know, because you know, even the slightest discharge, electrostatic discharge, might ruin them, and that is really not pleasant. I mean, they're not extremely expensive, these chips, but they are becoming rare. Okay, so yeah. Also, before you mount the chip, you have to make sure, there you go, okay, before you mount the chip you have to make sure that the whole device has been powered off for at least, say, 5 minutes or 10 minutes, okay, before you insert the chip. Alright, I bent, or I straightened the pins somewhat, and I used a duckbill plier to do that. You know, you'll notice these pliers don't have any serrations or anything, so if you, and when you squeeze the pins of an IC with this type of pliers, you won't damage the leads, right, or the pins. So ideal to bend a bit the pins of an IC, always use a duckbill non-serrated plier like this one. Second attempt, I bent the pins a little bit more. So let's see if I can fit it into the socket. You know, yeah, I know I called it a foot for the IC because in my language we call it a foot, not a socket. But there you go. Come on. Yeah, I mean, it's really hard to get it right, you know. You don't want to destroy the chip because it's, well, like I said, these chips are starting to be rare, you know. So, oop, you really don't want to, destroy them, you know. Yeah. There you go. Just need to push it a little more and it should be seated correctly. Yes, it is. Okay. It's seated correctly as far as I can tell. No pins are bent. No pins are bent. So I think we can try to switch it on. What do you think, guys? Do we try it or do we not? Let's try it. I mean, yeah. Why not? Okay. There we go. So 3, 2, 1. Okay. Oh. Nothing. It's dead. Yeah. So yeah, why doesn't it work? That's a good question. The radio doesn't work either. Oh dear. Well, the replacement chip didn't work. Apparently, it's not warm. Yeah. So now, no cigar. Close, but no cigar. Okay, so back to the drawing board. Okay, so the radio does work, as you can tell. Um, I checked the wiring to the speaker, and apparently, yeah, the wires had shaken loose, so I resoldered them, and that's okay. So the radio still works well, in fact, but the clock still refuses to work. Now I inserted the old chip just in case, I mean, it's for sure it's broken, but I mean, just to test things out, I thought, why not insert it and then see what I can still get out of it, if anything. But no, it's really dead. So what I'm doing now is I'm systematically measuring all the components on the display board right here. Okay, so I'm measuring all the resistors first, and then I'll see about testing the transistors, even the capacitors maybe, and then if nothing conclusive surfaces after measurements, then I think I'll have to, well, start looking much deeper into it, because right now I can't seem to find a smoking gun. So far I've checked out all the components, let's say the passive components, so capacitors and resistors, and most of them check out. I measured a few Zener diodes, specifically the Zener diode here, the D103, okay, and I measured the D102, which is also a Zener diode, and they both check out. So what I'm going to do next is I'm going to start measuring some transistors, and one of the transistors that I suspect may be causing a problem is this one right here, and that is the, let me see, that is the T104, which is a PNP, and its type number is BC328. Now, unfortunately for me, the engineers didn't find it handy or desirable to print out the names of all the components on the board, especially the transistors. Don't ask me why. They just didn't silkscreen the codes for the transistors. Well, not all of them anyway, which is really annoying. But okay, I did manage to localize that one, which is in fact that one on the schematic. That one over there. And that is the one that regulates the brightness for the display. So yeah, I'm going to check it out, because somehow I find what does work of the display very faint, you know. So I want to have a well working display to be able to test out the rest, right? Okay, I connected the BC328 up to my little tester, and it tests okay, except that every time I tested, its beta factor keeps changing, you know, that which is marked as HFE on the screen. Yeah, so the measurement before was 288, now it's 309, and let's see if it changes when I measure it again. No, now of course it stays the same. But either way, the fact that its amplification factor is changing every time I measure it, or nearly every time, is a little bit suspicious to me. So I am going to look for a replacement transistor, just in case. Well, there you go. Now it's 288. See? So yeah, I don't know, it's just not reliable enough to me, that transistor. So I'm going to look for a replacement transistor for the BC328. I'm really beginning to hate this Clockradio. When I think I've solved one problem, another pops up. The display module is connected to the main board via this flat cable here, and inside are stiff wires. Okay, so full wires, yeah, not stranded. But I need to work on this display, and for that I need to have access to both sides of the display. And when it's mounted on stiff wire like this, eventually, of course, it will break off. And that is exactly what happened. A few of them broke off, which of course started to give me all sorts of faults on the display, which in turn, of course, made me very nervous, and I slipped with my desoldering gun on one of the display elements. I mean, it's okay, the element, it will display the number, and you won't see it once it's mounted back in the case, but it's really irritating. Not only that, but the copper pads on the print board, on the PCB, are really weak. They can't withstand a lot of heat, at least not for a long time. You can't dwell on them too long, or they'll just let go of the PCB. So yeah, I'm really not happy. I'm extremely frustrated with it, actually. I'm just losing time right now trying to rectify the design errors, in my opinion, of the Sonoclock. So what I'm going to do is I'm going to solve at least another problem, which is the flat cable here, and I will continue the repair of the Sonoclock in another episode. I mean, my window of opportunity to finish this project is almost done, and yeah, I really need to move on. Also, I'm going to take a break because I really need one, and well, you will see me, or hear from me rather, yeah, by the end of the summer vacation, which would be somewhere end of August, beginning of September. So there, I'm sorry to have to leave you all on your hunger, so to speak, but I mean, yeah, I'm just getting very nervous right now, and I'm not getting anything constructive done on this project, so I better leave it off where it is now and then continue in the next episode. So thanks you all for watching, and oh, by the way, thank you, all of you, all my viewers and subscribers, for lifting my channel over the 1000 subscribers. The very first time in the history of my channel that I passed the 1K subscribers. I'm really grateful for that, guys, and I hope I'll show you many videos to come, and I hope I'll reward your subscribing and your viewing in a fitting manner in the future. So thanks a lot for watching. Thanks again for lifting me over the 1K subscribers, and I'll see you all soon by the end of summer, once you and I will all be rested and ready for another series of episodes. Bye bye, and have a nice summer vacation.